So for the work that I will present here today is from Horizon Europe project that recently ended, and the acronym is FlexForest, where the goal in a simplistic way was to create an open platform that is based on data spaces and also digital twins, where digital twins have been implemented using asset administration cells, in order to make available services that are related to resilience assessment and also reconfiguration strategy. So in order to proceed to the next slides, I would like to explain what are the resilience assessment strategies and what are the reconfigurations. So consider a resilience assessment services like proactive or reactive services that can assess the ability of a system to adopt, withstand, or overcome a cost disruption. So in cases that the system is not resilient, so the score, let's say, is not good, the idea was to utilize a reconfiguration strategy in order to quickly adapt to a cost disruption. So this project utilized both toolboxes under an infrastructure, let's say, that is based on data spaces and AASs. And these technologies have been used and applied into 4 use cases. So just to go on the concept level, on the motivation, so in manufacturing there is a need to collect signals from external or internal sources related to data that can cause a disruption. So for example, looking at the external signals can be like the geopolitical signals, can be economical, can be demands for the market, pandemic, for example, or other kind of things like regulations that can create a deviation to the plan that a company is utilizing. Now, looking at the internal are signals that are related to machines, to the workforce, or other internal reasons that can cause a disruption or deviation. So the first thing and the first challenge that we wanted to tackle is how we can gather this information. And this was the main idea to use digital twins, where we implement them using asset administration cells to capture production data, but also signals, external and internal. And secondly, there is a need of exchanging this information. And data spaces here are utilized in order to increase manufacturing resilience by enabling a trusted and interoperable way to exchange data. So this allows manufacturers, but not only, but suppliers and technology providers to share specific data. Share data related to demand, to inventory, to machine status, or in general logistics or disruptions, let's say. And why this is important? Because under a same common language and common policy, this data can be shared and utilized firstly for early detection of a cost disruption, secondly to assess the system's ability to withstand the disruption that is caused, and finally, if the system is not able to withstand or adapt, to compute a reconfiguration strategy. So that's why we use Gaia-X and IDS data spaces. I will explain in the next slides how we use them in a combination. And the main idea is that the AASs are there to have a common vocabulary, and the services, the resilience assessment and reconfiguration strategy services could be utilized from the ecosystem, if I may say. So here there are different strategies and different services in general, if I may say, that have been developed for 3 different levels. So starting from the macro level, macro is defined like supply chain or value chain, then is meso, is about the production system, and finally the micro, that's about the devices or machines. So different approaches for different needs, reactive or proactive services regarding the resilience. So this is the approach of the project, where the first goal was to bridge the IDS and Gaia-X through a computer data setup. So on top you can see there is a computer data environment. And the main idea is that this computer data environment through this computer data environment, someone can access either data from Gaia-X, where we implemented using Pontus-X, or from local sources, for example, an AES middleware or ERP, MES, or other data sources that the company has and can utilize. And finally, from IDS as well. So just to explain further what is the idea here. So the idea is that due to the fact that companies don't want to share some sensitive information regarding the bill of materials or the processes that they have or how they operate, there is a need to simply utilize or download, deploy services that have been designed and tailored on top of their needs, and that the final goal is not to expose their sensitive information. So that's why we designed this concept where IDS here in this project was used on the supply chain because we wanted to exchange some production demands, and Gaia-X was used to exchange data but also download and deploy services in a local environment. In total, we had 4 use cases, all from steel sector. But today I will mostly focus on the first one, that is on the macro and meso. The selection of these use cases is mostly about to show you how we use both data spaces, IDS and Gaia-X in a combination. So Sidenor Group is a group from Greece that they produce several products for the global market, but also their materials, they supply their raw materials from the global market as well. So in total they have 5 production facilities, but also 9 warehouses and operation facilities that they have. So 14 facilities in total. And what they produce is produce several products that are, for example, merchant bars, plates, wire rods, and more. So I will explain here what is the idea and why we utilize them and how we utilize the data spaces. So firstly, on top you see there is the headquarters. Everything starts from there because it's like the SAP and the system that they use in order to collect all the different signals regarding the demands, the prices, etc. So the first step is that we parse data from SAP and SAP IBP into asset administration cell models. Specifically, we use models from IDTA. And regarding the resilience part, as a project, we contribute to IDTA by submitting an IDTA submodel where you can find it and it is related to resilience. And the idea is how you can capture external and internal signals. So after we pass this information into AASs, these data were available through an AAS middleware. And then on the headquarters level, these data were utilized by a master production scheduler. And the idea here is to utilize this information and compute inventory plan, sales plan, scrap plan for raw material plan, if I may say, production plan, operational mode plan, so how each plan will operate, and also logistics, and that can be, let's say, summarized like supply chain plan. So, but the idea here is that we don't compute just one, but more than one. And that's why we want to apply different business strategies. So after having, let's say, X number of master production schedules, then the idea is that we utilize this supply chain resilience assessment in order to filter it and just select the one that is the most robust. And here comes the data space, because now we have the need to exchange this information. So as I previously said, they have 5 production facilities, and now what we did is that we exchanged this information from the headquarters to the plant using IDS. So this was the first step. And then the second step is that we set up in the production, in the plant environment, a compute-to-data environment where the services were downloaded and deployed using Pontus-X. So just to show it in more details, I will try to explain it very simplistic. We will start from the green side, where the green side is the IDS. So the data, as previously mentioned, from SAP and also SAP IBP parsed into AASs, and then AASs were available through the IDS data space. So two services have been deployed like software as a service and could be triggered from the compute-to-data environment that are related to supply chain, the ones that I previously showed you. So after these services have been triggered and a new supply plan has been computed, the allocated demand is sent to the plan. So what it means that we send this information to the compute-to-data environment where it is set up in a local environment of the CDNR plan. And here, the remaining services were available through the Pontus-X ecosystem. So the local compute-to-data environment, probably you have seen it in the past, is the Nautilus, as we say. It is part of the Pontus-X ecosystem and is a framework that using the wallet, you can buy services and you can, in a sense, automatically deploy them. This was something that we did within the project to automate this process, and when you buy something, you could deploy it and run it in a local environment like a Docker image. So after having the services here, what is next is in the compute-data environment, what is next is to utilize the data from local sources, so production data that were passed into AASs, and then utilize the demand. So the demand came like a number about how much the company can produce for specific products, but then was a need to pass it into products, specific products. So this was mainly the idea of how we utilize the data spaces, and in this project the main idea was to use both under a specific scenario. Of course, can be used in another way, that for example we can use Gaia-X on supply chain and IDS for the deployment of the services. Probably in another way. But this is how we test them and how we validate them into the use cases. So now, after following the completion of this project, of FlexForest project, all this knowledge about how you can implement data spaces in combination with AASs is transferred in one of the projects that Cosmas previously mentioned, and the one is the C++. So this is a Digital Europe project. And the main idea here is that we use data spaces in a combination with asset administration cells, but now for the plastics. So the goal is circularity, and in details, the goal here is to make available services and data, like assets, through a data space that the ecosystem speaks the same language, AASs, and these services can be easily utilized. So again, here the goal is to have SMEs within this ecosystem, and that's why we try to utilize data spaces in order to have same policy, same rules, same language. So thank you very much. That's all from my side.